Hey, Algebra 2 and non-Algebra 2 students, Mrs. Fallon back here. We are on page 305 of your student journals. What we're going to be looking at today is section 10.5, which is about permutations and combinations. And so what that really is the number of ways in which things can be arranged, which sounds a little bit strange, but there are two different ways in which, like items can be arranged. One where order matters and one where order doesn't matter. And so when we get into some examples, I think it'll make a little bit more sense. But let me kind of get into it for a little bit. So first of all, a permutation, just going to kind of zoom in on here, is an arrangement of objects in which order is important. So okay, so like for example, if we were going to list all of the different all the different ways in which, let's say, ice cream flavors of strawberry, chocolate, and vanilla were arranged. If you're going to do chocolate, strawberry, vanilla, that is a different permutation or a different order than if you did, vanilla, strawberry, chocolate, because the order in which you arrange them is going to make a difference. So that gives you a different outcome. All right. So like if you have chocolate in the first spot, as opposed to chocolate in the second or third spot, those are all three different kinds of arrangements. And so a permutation means that the order of those objects make a difference. All right, factorial. So factorial is kind of a fun little symbol in mathematics. It's an exclamation point. And so what it is, it's a product, which just means multiplication, of integers, which are just kind of like negative and positive whole numbers, 1 to n. In other words, it can go on forever. So for example, you might see something that looks like this. So this is a new symbol. So this means 4 factorial. You don't see this too often outside of, statistics work. But that's what that means. And so to calculate this, and I'll show you where you can find that on your calculator, but to do this by hand, what you would do is you would start with whatever number is here, and you're going to multiply by every consecutive integer that follows it. So like, for example, this would be 4 times 3 times 2 times 1. And so we stop when we get to, obviously we're not going to multiply by 0 because that would cause everything to be 0. So we're going to stop when we get to 1. So 4 factorial would then be 12 times 2, which is 24, times 1, which is 24. So 4 factorial, and especially if you do this in your calculator, which I'll show you in a little while, would equal the value 24. And so it's just a way to kind of write larger or patterns in a little bit easier way, rather than saying, like let's say you had 20 factorial, rather than saying 20 times 19 times 18 times 17 and all the way down, you say 20 factorial. Again, not outside of statistical work, you probably won't see that too often. All right, next one is a combination. And so this one is a selection of objects in which order is not important. So again, kind of the opposite of what a permutation is. So whether I pick chocolate, vanilla, strawberry, or strawberry, chocolate, vanilla, I'm still kind of choosing between the three same flavors. So that counts as one option. Now, if I did chocolate, strawberry, vanilla, and then, chocolate, strawberry, and butterscotch or something like that, then that's obviously a different combination. The binomial theorem is something we're actually not going to get into. In honors, we've already talked about this. So this is, remember that Pascal's triangle and that sort of thing. So I'll let you guys kind of look that up on your own if you're interested, for those of you who haven't learned that. There's a couple formulas we're going to add to our list, and this is called our permutation formula. So I'm going to have you circle this one. And this one is the permutation of objects. So this would be the one where order does matter. Order is important. So it's NPR is kind of what it looks like. And so we use factorials within our calculation of this. So again, this will make a little bit more sense once we get into some of our examples. So what I'd like us to do is, and then let's go ahead and look at the next And then we'll add this to our list here. The next page is your combinations formula. So remember how we talked about permutations and combinations. So these are two different formulas that we're going to add to our formula page. So let's go ahead and grab your formula page. And now I'm just going to add these two with it. And grab mine. And so this one I'm just going to, this is a combination. So it's NCR equals n factorial, and I'll show you how to use this here in a bit, over n minus r factorial times r factorial. It's kind of a weird looking formula, but and so what I would write here is that order is not important. And then let's do the permutation. And this one is very similar. NPR just has a little different formula. This one is n factorial over n minus r factorial. And this order is important. So you're going to want to have those written down. I'm going to show you how to do this on your calculator, but I also want you to be able to do some of the more basic ones by hand. And so what we're going to do is now is we're going to kind of turn to our we're gonna turn to our like extra notes, so that way we can kind of go through a few of these examples. All right. So if you grab out your extra notes, actually, the way I had this printed, and maybe you fixed it, but mine starts at the bottom of page 7, so that's 10.5 on the bottom of page 7. All right. So so it says, consider the permutations, so again, keyword here, permutations, of the letters in the word pencils, P-E-N-C-I-L-S. So it asks, and this is unfortunate that's on the next page, but it asks, in how many ways can you arrange all of the letters? So if they're asking for a permutation, what that means is that the order is important. So the way we can, so P-E-N-C-I-L-S is one order, right? P-E-N-C-I-S-L is another order. So in other words, if I change any of the letters and put them in a different spot, then those are all different permutations. So what I'm referring to here is like, this is one arrangement. But if I just mixed up one set of letters, for example, just the L and the S, that's another arrangement. So it would be rather tedious to try to figure out all those by hand. So this is where that formula is going to come into play. And so the permutation formula will work. So you could use and that's the one that we used with the NPR. And so what this means is if you're taking, a lot of times what we use this for is if you're taking, like if I wanted to look at all of these letters here, so there's 1, 2, 3, 4, 5, 6, 7 letters, and I want to take them, I only want to look at arrangements that are made up of 3 letters each. So for example, in part B where it says, in how many ways can you arrange 3 of the letters? So what we use this formula for is when we want to arrange the letters, if we're not looking at arrangements that include all 7 letters. If you're looking at arrangements that include all 7 letters, that's just that factorial. So that would just be 7 factorial. So 7 times 6 times 5 and all the way down. You could still use this formula, but what you'd be doing is the same thing. So like I could do, there are 7 letters and I want to take them 7 at a time. And so if I plugged these numbers into my formula, it's going to equal the same thing as what 7 factorial is going to equal. And so again, the difference between when I kind of use this formula is if I'm looking at a list of letters or numbers or whatever it is, and I want to arrange them in like smaller groups. Like, so again, you'll see something like it says you're going to arrange them in group, letters of 3 in a group, or taking 2 at a time, that kind of thing. So 7 factorial, and just to kind of write it out, just means 7 times 6 times 5 times 4 times 3 times 2 times 1. Now you can do this, you can do it in your head, you can do it probably not in your head, but you could probably do it on your calculator fairly easy. Just do 7 times 6 times 5 and all the way down. But I want to show you where you can use the factorial button. So if you hit 7, and then what I'd like you to do is find the math button. Okay, that's there. And then if you scroll over or arrow over to where it says, whoops, probability. So do you see the three things that we're going to be looking at here? This is the NPR, which is that permutation formula, the NCR, which is that combination formula, and then number 4 is that factorial. So let's just do factorial, hit enter. So it says 7 factorial, and you get 5,040. So this is just doing this math for you. So there's 5,040 different ways in which we can arrange the letters in the word pencil. Seems kind of strange, but that's what it is. All right, so let's do the 3 letters at a time. So now we're going to use this formula. So we have 7 letters. We're taking them 3 at a time. In other words, I want to look at, so like one combination might be pen, P-E-N. One might be L-I-S. One might be C-I-N. You know, any group of 3 different letters. So again, pretty impossible / tedious to try to do this all out by hand. So what we're going to do is we're going to follow the formula. So the permutation formula says n factorial over n minus r factorial. So I would like us to do this by hand, and you can use your calculator to check your work. So if this were on a quiz or even like something you're turning in for me, I would like to see you work out the math here, and then of course you can check your answer using the formula that I'll show you on the calculator. So n is always going to be the number of total letters. R is how many you're looking for, like the groups of 3, groups of 2. So n factorial in our situation would be 7 factorial. And then n minus r, so 7 minus 3 is 4 factorial. So one of the ways I want you to kind of think of this, if I like expanded out 7 factorial, and I expanded out 4 factorial, all of these values would end up canceling out, right? Because the 4, 3, 2, and 1 are the same from the numerator to the denominator. So this is why I want you to kind of do this out by hand. It's because I want you to see kind of what's happening here. And so then all you're really doing is 7 times 6 times 5, which is 30 times 7 is 210. So there are 210 ways in which you can arrange 3 of the letters. So again, I'd like to see work kind of used out, so the formula and then the numbers plugged in and kind of what you're doing, and then obviously your final answer. All right, let's do a couple other examples. 8 people serve on a committee, and how many different ways can a chairperson, a recorder, and a treasurer be chosen from the committee members? Okay, so is order important? So it shows a chairperson, a recorder, and a treasurer. Order would matter here. That's what you have to decide. Is order going to make a difference? So is it a different combination if I have, let's say, 3 different people, I don't know, Sarah, Rick, and Tom, okay? If I have Sarah to be the chairperson, Rick to be the recorder, and Tom to be the treasurer, but then I change it and put, Tom as the chairperson, Sarah as the recorder, and Rick as the treasurer, that's a different permutation. That's a different arrangement. So in this case, order makes a difference. So this is how you know you're going to use a permutation. So we're going to look at, we're going to use the permutation formula. We're looking at 8 people are total, so that's 8, that's our n, and we're looking for 3 different positions. Okay, so those 3, the chairperson, the recorder, and the treasurer. So 8p3. So if you're going to follow the formula, n factorial over n minus r factorial. So this would be 8 times 7 times 6 times 5, and I'm just going to write it like this, just to kind of save some time. Because 5 factorial means 5 times 4 times 3 times 2 times 1, and then 5 factorial means 5 times 4 times 3 times 2 times 1. So what you're getting at is those 2 things cancel, and then if I multiply those together, I would get 336. Let me show you how to use this in your calculator. So same kind of deal. What you're going to do is go to math, and then you're going to arrow over to probability, and then you're just going to hit the NPR, which is option number 2. Hit enter, and then it should bring you up kind of a template here, and so you can plug in your numbers. So I'm just going to 8, and then I'm going to arrow over and hit 3, and I should get 336, which I do. So it does all the math for you, which is fantastic. But I'd like you to also understand what the formula is actually doing in your calculator. All right, let's move on. Drea and Brian are auditioning for a part in the school play. There are 15 people auditioning. And then it says, and the order of the auditions is chosen at random. Find the probability that Drea auditions last and Brian auditions second to last. Okay, so we're doing probability here. So this is a little bit different. I'm just counting the number of ways we're talking about probability. So we're looking at a probability is the favorable outcomes over total outcomes, right? So if we're looking at the total outcomes, there are 15 people. So total outcomes would be 15 factorial, because it's 15 times 14 times 13 times 12 and all the way down. You can use the permutation thing, right, and PR, but again, it's the same thing as just doing 15 factorial, because the n and the r in this situation would be the same. If we're looking at find the probability that Drea auditions last and Brian auditions second to last. So what that means is there are 13, so favorable outcomes, because Drea and Brian are two of the people, right? That means there are 13 factorial combinations in which Drea and Brian could be auditioning last and second to last. So our total possible outcomes is 15 factorial. Our favorable possible outcomes is 13 factorial. So the probability would be favorable outcomes over total outcomes. And so again, if you think of it as this is 15 times 14 times 13 factorial, and then the 13 factorials will cancel. And so you get 1 out of 210. So there are one time out of 210 in which Drea auditions last and Brian auditions second to last. All right, number 4, count the possible outcomes of 4 letters chosen from the list P, Q, R, S, T, U. So on this one, they're looking for combinations. So we're switching gears now to combinations. So we're talking about the NCR equation. Similar, obviously, in the sense that but the only difference here is that order doesn't matter. So whether I choose PQRS or SRPQ, that's one combination. So again, the order is not important. So the formula is n factorial over n minus r factorial times r factorial. A little bit more complicated formula than the other one to account for the fact that order is not really important. All right, so let's use what we have. So there are 6 possible. There are 6 possible choices. So that's 6 is our n, and we want 4 groups of 4 basically. So this would be 6 factorial over 6 minus 4 would be 2 factorial times r factorial would be 4 factorial, because r is 4. So this would be 6 factorial over 2 factorial times 4 factorial. Okay, so I'm going to go ahead and just show you how I would reduce this. This is all multiplication. So this is 2 times 1 times 4 factorial. So see how I got the 4 factorials to kind of cancel out? It gives me a little bit easier deal. So 6 times 5 is 30. 30 over 2 would give me 15. And so there are 15 different combinations in which I can arrange those letters in groups of 4. All right, and then I'll show you how to do this on your calculator as well. Very similar to what we did in the last one. All right, you are listening to music. You have time to hear only 3 songs from your playlist of 16 songs. How many combinations of 3 songs are possible? So this is a combination because whether you listen to the order in which the order doesn't really matter here. So if you're only listening to 3 songs, whether you listen to your favorite one first or your favorite one last doesn't really matter. So again, we have 13 songs and we're looking at 3 at a time. I'm sorry, 16 songs, I apologize. 16 songs and then 3 at a time. So our formula would be n factorial, so 16 factorial over n minus r, which would be 13 factorial, times r factorial. So again, I'm going to kind of write this out, 15 times 14 times 13, because I'm going to try to get all this to cancel, or as much as I can. And then 3 factorial, I'm just going to kind of write out like that. So the 13 factorials would cancel. And if I did the math here, I get 3,360 on top and 6 on the bottom, which gives me 560. All right. Obviously, there's the math kind of worked out. Let's go ahead and use your calculator. Hit math, go over to probability, and this time hit combinations, which is option number 3. So we did 16 and 3, so just type in 16, arrow over, hit 3, we should get 560. So again, obviously the calculator works a little nicer because it's a little quicker, but I do want to see the math kind of worked out in this problem. All right, let's see here. Let's look at one last problem before we're out of here today. So, number 6, the art teacher has selected 13 projects, including one of yours and one of your friends, to use in a display. The projects, are placed at random. There is room for 2 projects in the middle row of the case. What is the probability that your project and your friend's project are placed in the middle rows? So again, we're looking at favorable outcomes over total outcomes. So again, we're talking about probability here. So the key word is this probability, which is favorable outcomes over total outcomes. So you kind of keep that in the back of your mind. So first thing I want to do is figure out how many total outcomes I have. So if I have 13 projects, and then you have to also determine is this a combination or a permutation. And then you want and you're looking for basically the middle 2. So you want 2 of them. So does it matter if yours comes in the middle, like if yours is first and your friend's is second, or if your friend's is first and yours is second? It says they only have 2 in the middle row. You want to know the probability that your project and your friend's project are placed in the middle row. So it doesn't say that you have to have them in a certain order, like yours has to go first or your friend's has to go first. So this would be a combination. And we're going to look at 2 because we're only looking at that middle row. So the only 2 that we care about are the 2 that go in the middle, so you and your friends. So how many different ways I can place 2 projects in the middle there? So I'm going to follow that permutation or the combination for formula. So I would do 13 factorial over 13 minus 2, which is 11 factorial, times 2 factorial. So 13 factorial, or 13 times 12 times 11 factorial over 11 factorial times 2 factorial. So anyways, I'm going to get 78 total. And if I'm looking for favorable outcomes, out of this, because order didn't matter, there's only one outcome in here, whether it's you first and your friend second, or your friend first and you second. Because the order didn't matter, there's only one possible outcome. So it's 1 out of 78 with probability. So there's a total of 78 and 1 is your favorable outcomes. All right, so that's it for now. If you have any additional questions, make sure you bring them to class. Thanks.